Hi guys, this is the fourth module now, problems arising from pesticide use. If we quickly just have a look at our syllabus, we can see we have a discuss question here looking at what is the long-term effects and consequences of using new pesticides, the effect on non-target species, so the species we don't want to be getting rid of, accumulation in an individual organism, so bioaccumulation, as well as the accumulation throughout a food chain, which is called biomagnification, and looking at human health impacts. Then we have to assess the alternative management practices that don't require the use of pesticides. And we have to gather to identify a pesticide and gather and analyze information. So we have to look at other sources to identify which pesticides or more than one have been banned, and summarize its use, the reason they were stopped, and use available evidence to assess the impact of its residuals, so leftover chemicals in the environment, and also gather and analyze information from secondary sources about the alternatives to pesticides as a management practice, as in managing the pest itself, because pests can cause a lot of harm and damage to crops, agricultural purposes. So Australian soils are naturally low in phosphates, and native flora have adapted to these low levels. Most crops need higher level of nutrients, including nitrogen and phosphorus. So fertilizers have been used in some part of the country for over 100 years. Monocultures, which is if we have crops that are specifically planting one type of crop, monoculture, are at risk of attack by pest insects, decimating the crop. So pesticides have been used really heavily in some areas. So our first dot point is to look at the effect of continually introducing new pesticides to the environment, including the 3 points that I just spoke about. So the use of pesticides can have positive and negative effects. Obviously, it can eliminate pests which would otherwise destroy crops, but it can also initiate long-term problems. A pesticide is a chemical which is synthetically designed to kill insects, weeds, and disease, and we'll have a look at what they're called in a second. Their use at time is essential to protect crops. Today, we have a better understanding of ecosystems, and we know that there are flow-on effects of harmful chemicals. And that's why we need to stop them. Today, farmers are being encouraged to use alternatives, which can eventually eliminate the use of all chemicals forever. So we've got herbicides. Okay, they're all toxic to living things. Herbicides, fungicides, and insecticides. So depending on if it's a weed that's affecting a crop or an invasive species of flora, whether it's fauna, small insects, or fungicides, which may be used to get rid of some diseases that are affecting plants. Synthetic pesticides, they're made in labs and they take longer to break down naturally. Because of that, that's why they end up sticking around for a long time and accumulating in the environment, because they don't easily get broken down. Whereas natural pesticides tend to break down a lot quicker and are less harmful therefore really are less harmful. Okay, non-target species. Basically, pesticides can often kill beneficial organisms as well as pests. So, for example, pesticides can kill predatory insects that would eat the insect pests, as well as economically imported insects such as bees that are commercially important to apiarists. As well, the animals that eat the poisoned insects and other animals that are further up the food chain can also be poisoned. So this is how we are changing the food web, direct or indirect poisoning, so directly poisoning other insects or by being ingested by those insects that have it. And then we've got biomagnification, which we'll talk about, and also habitat changes if we get rid of some aspects of that ecosystem. So bioaccumulation is basically when a type of chemical accumulates in the tissue of one organ, okay, and we're comparing that concentration of that chemical in that organism over time compared to the amount of chemicals left over in the environment. So is the net result of the chemical uptake, storage, and elimination. Okay, so overall, how much does that animal or organism keep that chemical inside its tissues? The difference is biomagnification. I'll just finish off by saying there are some pesticides, especially organochlorides and some organophosphates. They're readily taken up into and remain in the fatty tissue of animals. Single doses may not reach lethal levels, but because these pesticides are really persistent, the poison can accumulate if the animal is exposed to the poison over a longer period of time. Each time an organism is exposed to the pesticide, the concentration increases. The other way that a pesticide can persist in the environment is biomagnification. And you may have looked at what this is in your previous studies of ecosystems. It means that on the lowest level of the food chain, each of the organisms have a very small amount of that chemical. But however, as that organism or the consumer or the producer is consumed by the primary consumer, that primary consumer is going to have a lot more of those because they won't be only ingesting one of those producers but more. And as that primary consumer gets eaten, more than one of those gets eaten by its secondary consumer, that secondary consumer has a lot more of that chemical. So it might not be lethal in one of the animals, but because the animals in the higher food chain are feeding on those organisms, eventually it will lead to a lethal pesticide level. Okay, one example of this is DDT. The mammals that are not necessarily being sprayed by DDT are still accumulating DDT in their systems as if they had been sprayed because they're eating the insects or they're eating, let's say, the plankton that has taken up the DDT in the water. So we're starting with 0.000003 parts per million in the water, and the concentration increased over 10 million times because we end up with 25 parts per million eventually, which is a huge number in comparison. Okay, and we can see this again in another example. We start with a very, very small number, and eventually what happens? It increases greatly. Okay, here's another example of biomagnification. The bald eagle was severely affected but in the mid-20th century by a variety of factors. Among them was the thinning of shells, their eggshells. And that was because of the use of the pesticide DDT. Bald eagles, like many birds of prey, were affected by DDT due to biomagnification. It was not lethal to the adult bird, but it interfered with the bird's calcium metabolism, making the bird either sterile or unable to lay healthy eggs. Female eagles laid eggs that were too brittle to withstand the weight of the brooding adult, so made it nearly impossible to produce young. Alright, so effects on humans. Prolonged exposure to pesticides can lead to severe disorders in our reproductive, nervous, and immune system, and has also been linked to cancer. They include such symptoms and issues such as asthma, skin conditions, birth defects, neurological defects, cancer, and hormone disruption. A large number of pesticides are found to have these adverse effects, including, importantly, in the immune system and hormones, and a lot of them are identified as carcinogens. The use of DDT is a very good example of how pesticides can impact humans. Humans can still be exposed to DDT by eating food that contains small amounts of these compounds, Although DDT has been banned since the early 1970s, small amounts can be found in soil and still can be transferred to crops grown in the soil. Imported foods may also have been directly exposed to DDT, but the amount of DDT in crops has been decreasing and is expected to continue decreasing with time. Short-term exposures to DDT of high doses can affect the nervous system. People who have taken in high amounts of DDT experience excitability, tremors, and seizures. These effects on the nervous system appear to be reversible once exposure has stopped. Some people who've come in contact with DDT have complained of rashes or irritation of the eyes, nose, and throat. People exposed for a long time at low doses, such as people who were involved in the production of DDT, has some changes in the levels of liver enzymes, and there was no indication that DDT caused irreversible harmful effects. Okay, also we will talk about DDT again when we talk about the gather process dot point, where we have to talk about a banned substance, and there are some links that are provided in your worksheets for you that show us about the persistent organic pollutants and dioxins in Australia, and there should be a link there to the Greenpeace Australia Pacific meeting, the convention that was held, so that's worth a read about the main POPs. Okay, so make sure you do read that one. Okay, so alternatives to pesticides. So the best thing to do for this dot point is to gather as much information, alternative measures that are used by farmers and horticulturalists to control or prevent pests from eating crops. It's good to find some information that says how effective they are, and you might want to compare methods used in different countries. There's a couple that I can mention here and talk about a few others, and you can complete the activity in your worksheet that will guide your comparison process to be able to actually analyze the information. So look at how successful they've been in each situation. Okay, and that's what analyzing is, to look at all the data available. So I suggest, as I said in class, that you divide the work amongst yourselves and at least have a look at 2 or 3 examples and then share the information. Make sure you source everything that you get because that's the whole purpose of a gather and analyze information from secondary sources question. Okay, so there's many options to eliminate the use of pesticides. The first and most obvious is to choose plants appropriate for growth in the area. Native plants are often the best choice because most of our staple food crops are not native. Growing native crops is not ideal. Alternative, we can use rotating crops. This can disrupt a pest's life cycle or create an environment not suitable for its survival. This can eliminate the possibility of a pest to infest an area. You can also use physical barriers such as sawdust around plants to prevent slugs and snails getting to eating the plants, traps, tape around the base of trees, using nets to enclose crops to protect them from insects and birds, and wide metal strips can also stop slugs. Biological controls are like releasing an insect or a type of wasp that might lay eggs in another insect that is a pest and eats the crops. When the wasp larvae hatch out, they will eat the pest insect. So introducing some predator species can ensure that pest populations are controlled, but sometimes this doesn't go to plants such as the cane toad. And you can look that example up. It's quite famous, it's very easy, it's also in your notes. Okay. Genetic engineering is another controversial method to eliminate pesticides. It involves actually altering the crop to become more resistant. So for example, introducing genes from one crop to another will enable the new plant to produce proteins which the pest cannot tolerate, or make it less susceptible to pests. One of them includes cotton's resistance to weevils. You can look that up too. Alright, well, why would genetic manipulation be controversial? Because have a think about it and just think about if we manipulate one thing, the flow on effects, just like adding pesticides to an environment, may have effects that are not calculated that could cause an effect to the environment. Okay, we can also use other things, other management. Oh, are we not there yet? Okay. So you can use integrated pest management, which is actually using more than one different forms of control all at once, which allows farmers to reduce the amount of chemicals that they use. We can also use plant-derived pesticides. They can be potent as synthetic pesticides, but they break down more easily and rapidly without building up in the environment. There are also other things such as using decoy crops, so using crops that will attract pests, they will leave the main crop untouched. You can use herbs and companion plants where plant combinations work together in fending off insect pest problems. Actual research is not well established, but much of the information relates to experience and suggestions from gardeners. An example is garlic as a companion plant for fruit trees. When planted close to the trunk, the garlic seems to repel aphids and blight. Okay, that's the end of part one. Make sure that you complete the activities and have a read about all the different types of management.